Here in section 7.3, we're going to be looking at proving that a quadrilateral is a parallelogram. And in 7.2, we learned about several characteristics of a parallelogram. We're going to take that one step further today. Let's go ahead and start and take a look at Theorem 7.7. And Theorem 7.7 is about the parallelogram opposite sides converse. Now, if you remember when we began dealing with proofs, we have the theorems and we have the converse. And the converse is simply, once again, when we change the hypothesis and the conclusion, and then the conclusion comes first, the hypothesis comes second. So it says right here, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So if we know that AB is congruent to CD, what they're saying, we know that AB is congruent to CD, and BC right here is also congruent to AD, then we realize that we have a parallelogram. So if opposite sides are congruent, we have a parallelogram based off of the parallelogram opposite sides converse. On theorem 7.8, we have the parallelogram opposite angles converse. So right now, remember, we don't know that we have a parallelogram. But what we're going to determine, though, is because both pairs of opposite sides, or if both pairs of opposite sides are congruent and parallel, then the quadrilateral is a parallelogram. All right, so if the opposite, once again, angles of a quadrilateral are congruent, then we have a quadrilateral is a parallelogram. In theorem 7.9, it says we have the opposite sides parallel and congruent theorem. Okay, so right here, it says if one pair of opposite sides of a quadrilateral are congruent and parallel. So the same side that is congruent must also be parallel as well. Okay, so if they're both congruent and parallel, then the quadrilateral is a parallelogram. Let's take a look next up at theorem 7.10. We have the parallelogram diagonals converse. So remember, one of the things we know that in a parallelogram, the diagonals bisect each other. Well, in this theorem, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So if I know that BD is being bisected and AC is bisected as well, then we can go ahead and prove that parallelogram ABCD or quadrilateral ABCD is a parallelogram. So how do we prove a quadrilateral is a parallelogram? We mentioned the several different theorems already. And so right here, we have it in 5 steps that they're showing. We want to show, number 1, that both pairs of opposite sides are parallel. That right there is a definition of a parallelogram. Or we could show that both pairs of opposite sides are congruent, which is the parallel opposite sides converse. Number 3 is to show that both pairs of opposite angles are congruent. That's your parallelogram opposite angles converse. Then we show that one pair of opposite sides are congruent and parallel. There's your opposite sides parallel and congruent theorem. And then the 5th one is to show that the diagonals bisect each other with the parallelogram diagonals converse. All right, so many different ways for you to be able to show or prove that a quadrilateral is a parallelogram. Let's go ahead and take a look at some of our extra practice right here. So it says, state which theorem you can use to show that the quadrilateral is a parallelogram. In number 1, things that stand out to me is we have these two sides, opposite, one pair of opposite sides are congruent and parallel. All right. So that right there would be your opposite sides, parallel, and congruent. Number 2. Looks like we don't know that, once again, we don't know that this quadrilateral is a parallelogram, but things that stand out, look at these opposite angles, they're congruent. So therefore, we have parallelogram. We could say parallelogram, opposite angles converge. And I'll go ahead and use, what is it? An image right there, or a little symbol to represent a parallelogram. We'll have opposite angles converse. And don't forget to make sure you add converse. On number 3, I see that right here, we got these diagonals. They are being bisected. So therefore, we have ourselves a parallelogram, diagonals, converse for number 3. So let's go ahead and use that as our answer. Let's go ahead and move on to number 4. Find the values of x and y that make the quadrilateral a parallelogram. All right, so thinking about what do we know about a parallelogram or a quadrilateral? That's a parallelogram. Okay, so remember, if this quadrilateral is a parallelogram, then we should know, 1, opposite angles are congruent. Okay, so that's one thing. But if I look at the opposite angles, the 3x minus 20 and the 4y, we have a problem there because we have we've got two variables, right? So if I set them equal to each other, I'm not going to be able to solve necessarily for x and y. We can, but I think there's another easier way for us to go about this problem. What we could do right here is look at the 3x minus 20 and the x plus 40. Okay, if this is a parallelogram, then remember those two consecutive angles will end up being supplementary. So what I can do is take 3x minus 20. I'll add x plus 40, and it's, we put the parentheses there for good practice and for organization. And since they're supplementary, it's equal to 180 degrees. So now we can go ahead and solve for x. We'll simplify, combine like terms. So I got 4x. Let's see, negative 20 plus 40. We have ourselves plus 20. That's equal to 180. We can go ahead and subtract 20 to both sides. 4x is equal to 160, and divide both sides by 4, and x is equal to 40. All right, so we have x is equal to 40. That's step 1. So now from there, we could say, or we could do the same thing again and use these two angles right here, the x plus 40 and the 4y. And from there, we could say that, hey, those two angles are supplementary. Or we could use opposite angles are congruent. You could take your pick. Let's go ahead right here. I'll say opposite angles are congruent. So I've got 4y is equal to 3x minus 20. And what I can do now is substitute x with 40 and then solve for y. So I got 4y now is equal to 120 minus 20. 4y is equal to 100. Divide both sides by 4, and y is equal to 25. All right, good stuff. Let's take a look next at number 5. It looks like they give us some information on diagonals here. And what do we know about diagonals? They bisect each other. Therefore, this 6x is congruent to this segment over here of 4x plus 10. We should also realize that this 2y is congruent to this segment of y plus 1. So it works out perfectly since we don't have, since those diagonals happen to have the same variables. So let's take 2y. I'll set that equal to y plus 1. And then let's go ahead, we'll subtract y to both sides, and I got y is equal to 1. For the x's, we'll go ahead, I'll take 6x. We'll set that equal to 4x plus 10. We'll solve for x. I'll subtract 4x to both sides first, and then divide both sides by 2, and x equals 5. Now, good thing for us, they're not asking to find how long each side is. They're just having us find x and y. But there are problems that may ask for you to find, well, how long is the segment? And if that is the case, then you're going to have to do a little bit more work and plug your numbers back in. All right, next up, let's take a look at number 6. Okay, so we got two things going on here. We've got one set of sides is parallel. All right, and if this is a parallelogram, then that parallel side should also be congruent. So I can go ahead and say that this 10, we'll set this 10x plus 7, and I'll set that equal to 12x minus 9. And so we'll go ahead and solve. It works out because we have x on both sides of the equation. I'll subtract 10 to both sides, or 10x, and I'll add 9 to both sides. And then we end up with 2x is equal to 16. Divide both sides by 2, and x is equal to 8. For the y's, it's pretty simple because remember, in a parallelogram, opposite angles are congruent. So y is equal to 106. Okay, so there you have our answer right there. All right, one last one. Let's take a look at number 7. All right, this is a parallelogram, remember, because they tell us in the beginning that make the quadrilateral a parallelogram. So we'll take the opposite sides congruent right here. Easiest way to go about this, and the only way, converse. And so let's go ahead and put 70 is equal to 4y plus 2. We'll go ahead and subtract 2 to both sides, and I have 68 is equal to 4y. After that, we'll divide both sides by 4. Oops. When we divide both sides by 4, right here, y ends up becoming 17. All right, beautiful. And then let's go ahead and figure out what x is. And let's take the 5x plus 16 is equal to 6x minus 1. And we'll go ahead and solve for x. We'll subtract 5x to both sides. And I got x, and we'll add 1 to both sides to end up with 15. Or sorry, 16 plus 1, that's 17. And both x and y happen to equal 17. All right, there you have it, 7.3, proving that a quadrilateral is a parallelogram.